Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem 401 binary watch. It's easy marked. Let's see the question. A binary watch has 4 LEDs on the top to represent the hours from 0 to 1. So why only 4? I will explain later. And 6 LEDs for bottom to represent the minutes from 0 to 59. And each LED represents a 0 or 1. So is are like a bit binary form. So either it will 0 or 1 with the least significant bit on the right. So for example, the below binary watch reads 451. So that means like in to represent hours we have 4 bits. Why? So to represent the numbers from 0 to 11 we need at least 4 bits. To represent the minutes from 0 to 59 we need at least 6 bits. Okay, now minutes are 6 bits, 4, 5 and 6. So here if you see hours are 0, 1, 0, 0. So 1, 0, 0 is 4 and the minutes are 1, 1, 0, 0, 1, 1. So this is 51. So the time is 4:51. Now let's see the real question. Given an integer turned on which represents the number of LEDs that are currently turned on. So what he will give is he will give an integer turned on, so which represents the number of bits turned on in this screen. So what that mean is, so we have total how many bits we have? We have total 10 bits, right? For hours we have 4 bits and for minutes we have 6 bits. So total 10 bits. So but he will give us the turned on bits. So within this range, right, we will give a number of bits like 2. That means 2 turned on out of 10. So if we give 3, that means 3 turned on out of 10, right? We need to find the combinations that it can generate the numbers, right? How? For example, if 1 turned on, so it can be between, it can be here or it can be here or it can be here or it can be here, right? And the remaining thing also 0, right? Now let's take an example. He's given turned on as 1, right? This is hours and this is minutes. For hours we have 4 places and for hours we have 6 places. Now let's see, if he's given as 1, that means the turn on is only 1. So if this is turn on, so remaining things will be 0, right? If this is turn on, remaining things should be 0, because out of these things only 1 should be turned on. If this is turned on, remaining things will be 0. Got it? Okay. Now what we'll do is we will try to generate the all hours. So we have 0 to 11 hours and 0 to 59 minutes. We'll try to create a combination out of this and we'll check how many bits turn on in the hours and in the minutes, and if this matches with the hour turn count, then we'll consider it as a consider it as an answer. So what we'll do, we'll iterate from int I is equals to 0 to I should be less than 12 and then I plus plus, and then another for loop for the minutes, int j is equals to 0, j should be less than 60 and then j plus plus. Okay, now what we'll do is we'll find the turned bits in the set bits in the hours. So what we'll do, we'll call a method called count bits in I. Okay, we'll store this as a hours bits and then minutes bits is equals to, we'll count bits in the minutes also in j. So this gives number of bits turned in the hours place and this gives number of bits turned in the minutes place. Okay, like how, like if it goes 0 and 1, like 0 2, like 0 3, 0 4 and so on, 0 comma 59. So like this we are going to generate all the possible time that we can show on the watch, and for each time we are going to count the bits, right? If we count the bits, and if this hours bits plus minutes bits is double equals to our turned on bits then we'll consider that into as answer and we'll add into the result list. Okay, we'll add result dot add our I comma j. Okay, our I comma j. So actually we need to return it as a string, right? We'll see how we can generate the string. We can use the string formatter to generate the format that he is given. So he is given the format as, so minute should not have a leading 0, right? So if it is 4, only 4 should return, and if it is for minutes, if it is 2, if it is a single digit, we should add 0 before to that minute thing. Okay, if you understand this. So for this counting bits, we have a method in Java called integer dot bit count. So this will return us number of bits in the integer number I. But interviewer will not be happy with this approach. So what we need to do is we need to write a separate method. So as I said, I will write a separate method count bits. It will take int n. Okay, so what it will do is, okay, let's see before one thing. Before I will write the numbers 0 1 0 1 0 1 0 1 0 0 1 1 0 0 1 1 and then 0 0 and then 1 1 1 1 and here 8 1 2 4 5 6 7 8. Okay, now if you clearly observe, what is the difference between this number and this number? Only this bit is changed, right? What is the difference between this number and this number? Only this bit is changed. What is the difference between this number and this number? Only this bit is changed. So if we observe the two adjacent numbers, only one bit is changed between them, right? Why? So this is 0 and this is 1, this is 2. So like this is 8, right? Sorry, this is 7. So if we clearly observe here also, only this bit is changed. So we need to count number of set bits in the given number. So what we'll do is we'll iterate this loop. We'll have a while loop while n is greater than 0. So what we can do is to get this least bit set bit, so we need to do AND operation with its below bit, right? What we'll do is, for example, given this number, right? This is 3. If we do AND operation with 2, so what it will give? 0 0 1 1 and then 0 0 1 0. If you do AND, 0 and 1 is 0. This is 1. This is, so it will give 0 1 0. What it does? It removed the rightmost set bit. That means one set bit is removed. Now we have 2. If you do AND operation with its n minus 1, if this is considered as n, then we will do n minus 1, which is 1. If you do it with 1, what happens? It is 0, this is 0, this is 0 and this is 0. So the set bit 1 is also removed. So how many times we removed the set bits? Only 2 times we removed. That means 2 set bits there in the number 3, which is n. Got it? So now what we'll do is we'll iterate this loop and we'll do n is equals to n and n minus 1 and we'll increase the count and we'll return this count. This count will hold the number of set bits in the given number n. Got it? So why I am doing n into n minus 1? Because the difference between the n and n minus 1 is only 1 bit. So if you do the ampersand, it will eliminate the rightmost set bit and it will really increase the count. Got it? Now let's write code for this. Let's take a list variable to store the results. List of strings in it. We'll store it as results is equals to new array list, and then we will iterate first I is equals to 0 to I should be less than 12 and then I plus plus. So this loop is for the hours and the next loop is for the minutes. Int j is equals to 0 to j should be less than 60 and then J plus plus. Now what we'll do is we'll count the bits in the hours and minutes. So hours bits is equals to count bits of I, and then int min bits is equals to count bits of J. Okay, so now what we'll do is we'll check if this hours bits h4 or s hours bits plus min bits is double equals to this turned on bits, then this is the result. So we'll add, this is one of the answers, so we'll add this into the result that add. We need to format the string, so we need a string that we will use string dot format. So for minutes we need only one thing, one digit, so I will use %f %d and then colon. For minutes we need 2 digits, so I will use %0 to d and then I and then j. So here it is integer j, so this is fine. Now this is fine. Now at the end we'll just return the result, and let's write method for this count bits. We'll take write a method public int count bits of int n. So what is it? We need a count variable, initially it will be 0, and what we need to do, while this n is greater than 0, we need to iterate till n is greater than 0, and we need to do n is equals to n and n minus 1. So it will return as the most right significant bit, set bit. So we'll update n, and then we'll update the count plus plus, and at the end we'll just return the count. Now let's try to run this. Yeah, it is accepted. Now let's submit this. Yeah, it is accepted. So if you like my content, please do like, share and subscribe, and write the time complexity and space complexity for this program in the comments. Thank you. Bye.